Hi, welcome to a beginner's guide to creating a complete 2D video game. My name is Pete Jepson, and I look forward to showing you how easy it is to make video games. In this series, you will be creating a complete 2D video game with 6 levels, an end of level boss fight, a main menu, a level select screen, and level accomplishments. Type Stencyl with a Y into the Google search engine. Now this is free software that you can use to make web-based games. So download Stencyl and choose whichever type of computer you are using. Once you have opened the software, you will see the Welcome Center. This shows you all the games you are working on. Now, if you have created an account, you can also take a look at Stencyl Forge, where you can download free stuff. But for now, let's click Create a new game and call it Mining for Jelly Beans. Now we are inside the dashboard for the game, where different types of assets, such as actors, backgrounds, sounds, etc., are organised nicely in categories on the left. Click on the Tilesets category to import the tileset for this game. Now this is the import window. Ensure the scale is set to 1x, otherwise you will import very small images. Now choose the tileset image in the level 1 art folder. It is automatically sliced up for you. Now click on the top block and you will see the collision options. This is set to square collision. Now make sure that the blank blocks have no collision. Click the X on the right of the tab to save this file. Now to import the player, click on Actor Types and create a new one called Player. Add an animation and then click on the Add Frame, choosing the Player Sprite Sheet. Now this needs to be sliced up by counting the columns and rows. There are 6 columns and 3 rows. This separates each image into its own frame. It is now playing all the frames in the preview. We just want the standing right and blinking, which is frames 14 and 15. So hold Shift as you click on frame 13 to select them all, and then remove them. Now remove the last 2 frames. Blinking is too fast. Double click on frame 0 and change the duration in milliseconds. Let's try 600. Okay, it's still too fast, but let's try 1200. Okay, that's much better. Rename this animation as idle right, as this is the animation played when you are not moving anywhere. The animation needs to constantly loop. Create a new animation using the plus icon at the bottom left. And repeat the previous process. This time you are wanting to select the idle left. Okay, now change the duration on frame 0 to 1200 milliseconds and then rename the animation to idle left. Now add a new animation for walk left. Now you may notice that the first 3 frames and then frame 6 belong together as the walk left. The animation speed seems pretty good, so rename the animation to walk left. Repeat the process for walk right. Okay, so now rename it to walk right. And then we're going to create another animation for the jump left. Now the last 2 frames are the ones that are the jumping animations. Now I want to start this animation from a standing left. So select the first frame in idle left animation and then copy it and paste it into the jump left. Okay, but it's the wrong order. So copy frame 0 and paste it in. Then delete frame 0 to get the right order. That's better. But now the animation is too fast. Double click on frame 1 and change it to 600 milliseconds. And then uncheck looping so the animation does not auto loop back around again. Repeat this for the jump right. Oh, but don't forget to rename the jump left animation. In fact, it is easier to copy the first frame of the idle right and then paste it into the new animation and then import the sprite sheet. Now repeat the process from the jump left. Okay, so the star on the idle right indicates that this is the default animation. Now you can set this by clicking the star icon on the bottom, but actually I want the idle right to be the start animation anyway. Close the tab to save. Now we are going to check the player's collisions. Double click to continue editing. Select the collision section and you will see each animation as its own collider, but they are all too big. So use these numbers to resize the box collider so that it fits just the bottom part of the character. Now move it down on the Y position. That's good. Now add a new circle collider and resize it, and you can actually drag and drop over the character's head. But the box is still too wide, so reduce its width and reposition it. Okay, that's much better. Now you will need to repeat this for all the other animations, and you can use these numbers as a guide. So I've now done all the animations and they should all have accurate colliders. Now for your first assignment, I want you to import all the graphics needed for the main menu and the first level. That's all these graphics, which you can find in the resources for this section. Sort out the colliders and the animations. Now you will also bring in the main titles and the play button alongside the 2D game objects. For the box and key, it should have two static animations for both box and key. For single frame animations, always ensure looping is unchecked. Now the collision for the key should match the graphic as closely as possible. This is just a graphic, so it doesn't need a collider. The door animation should end with the open black door, but without the stars on the end. Rename it to open and uncheck looping so it stays open. Now copy frame 0 and create a new animation, and then paste it in that frame and rename it as closed. The door shouldn't have a collider for either animation, so press the delete key to get rid of the collider, allowing the player to walk past it easily. Play mode character is a simple animation. The frame duration has been increased to 200 milliseconds. And for the collision, it is a small circle collider. The heart is 1 frame and has a simple box collider. And the collider on the jelly bean has been reduced a bit to fit closer to it. Now the play button needs a collider to detect when you are pressing it. This is the main title and doesn't need a collider. The water drop should have 1 blank frame at the end and looping unchecked so it doesn't repeat. Now rename this as splash and then copy frame 0, and then you can create a new animation. Now paste in that frame and rename this as drop. The collider for the water drop should be quite small. Okay, now the water spawn doesn't require a collider. And the wood platform should have a collider that matches the graphics. We are now going to create the main menu. Double click on the game icon to continue editing. In the scenes category, create a new scene and call it menu. These numbers are fine. Choose a blue colour for the background. This is the scene editor. Click on the actors section in the top right. And we are going to organise by layers, so double click to rename this as title. Now click the title actor once to select it. You don't have to drag and drop, just move to where you want and click to set the object in place. Do the same for controls. Now click the plus icon in the bottom right to create a new layer and call it Objects. Select the player and add him to the menu. Click back on the title layer and add the play button below where the player will walk. Back on the objects layer, add jelly beans. Click once to select and then click on the menu to set the jelly beans in place. Now this acts kind of like a rubber stamp. The menu has been created. Click on the physics section and add gravity. Set it to about 35. Now click the green test scene button. It will have to save and compile, and then it previews your game in a Flash player. Now most of the objects are now affected by gravity, so let's fix that. Go back to the dashboard and to actor types. Double click on controls. Go to the physics section and select cannot move. With this selected, it won't be affected by any physics in the game. Now do the same for the title and for the play button. The jelly bean is already set to cannot be pushed, so it is affected by physics but doesn't move. Go back to the menu and try testing it again to make sure that nothing moves. Now it's just the player that's falling, but that's easy to fix. Click on this terrain tool. Now click and drag a box on the scene. Now this is invisible, but the player can walk on this. And drag another box as a barrier to the right. Test the scene again. Now that's great. The player has a ledge to stand on. Now we need to get the player to move. I'm going to close these tabs to save memory. So back on the dashboard, double click on the player. And select the behaviours section and click the button to add a new behaviour, which is Stencyl's term for game coding. And as you can see, there are some free codes that come with Stencyl. Click on controls and select the jump and run movement behaviour. Now we need to configure this, so select the controls for the movement. And set the jumping force to 35 to make the player jump a bit higher. Now choose animations for each of these that match the names that are given here. And we also want to check jump animation when falling. Close the player tab to save and then test the menu scene. You can now control the player with the left, right and up keys on your keyboard. We need to sort out the collision for the jelly beans and also to stop the player from rotating. So double click the player again and under the physics section set can rotate to no. And also double click the jelly bean and under the collision section set the collider to be a sensor, meaning you can walk through it but still activate a collision. Great, let's test the menu scene again. Okay, so now it's working. So go back to the player and go to the behaviours section and click the add new behaviour button on the bottom left. Now under the motion you will see cannot exit screen. Apply this to the player. And test the menu scene again. And so now the player can't move outside of the screen. The menu scene is now almost complete. We are now going to take a look at the visual coding screen and get used to the basic events. Double click the game to continue editing. In the scene section, add a new scene and call it Test. And make the background black. Click once on a tile and click again on the screen to set a platform. Click in the middle section this time, click and drag to draw the platform, and then finish the other side with the right edge tile. Great. Now in the actors section, add the player to a new layer. And we also need to add some gravity in the physics section. 55 should do. Now go back to the dashboard. Go to the actors behaviors section and create a new actor behavior. Call it example. You get a message. You can take the crash course later if you want. So this is the visual coding screen. In the middle is the stage where the code is created. On the right are the commands, which are separated into categories. But the first thing that we need is an event. Click Add Event to see the list. Now events tell the computer when you want it to run a series of commands, and we are going to try out a few of these sections. So on Basics, click When Updating. This event runs every frame of the game. Now click the Actors section and Effects. Now let's add an effect. Click and drag to add this brick. And we will choose Brightness. Drag that into the white box. And it requires a percentage. Type in 0.5. Click Attach to Actor and choose Player. This makes sure the behavior is attached to the character. Now test the scene. The code should make the player now get brighter by 0.5% every frame. So let's see how fast the character is going to get really bright. And you can see that it gets bright in a matter of seconds because it's running every frame. Go back to the example behavior and this time add a when created event. You can drag the code out of the updating section and right click to copy. Now right click again in the creator section and choose paste and attach that to this event. Change this value to 40% and then uncheck the updating so that code will not run when played. Test the scene again. And now you can see the character got brighter, but the command only ran once when the object was created, meaning that he didn't turn fully white. Uncheck created, and now add a new event. And we will talk about this when drawing in a later session. Select an input, a keyboard event. Now select the control, choosing the left button. And make sure it is on pressed. We will add another effect. Drag the apply effect and then we will choose invert to go into the white space. Now add another keyboard event. This time set it to when the right is pressed. And choose remove all effects. So test the scene and you should now see that the character's colour becomes inverted when you walk left and it resets when you walk right. Notice the commands only run when you press the correct keys. Uncheck all the events to prevent them from running and add a new event. This time let's go with a mouse click, which is under input. For this one, go to the tweening section, which is an animation term for the animation in between keyframes. Choose the scale and drag it into place. Now anything larger than 100% scales the character up, and less than 100% shrinks the character. And this will be over 2 seconds. So choose the numbers and text and a random integer. Integers are obviously whole numbers, 1, 2, 3, etc. Whereas floats are decimal numbers. So 1.5, 2.3, etc. Now drag that into the first blank section and we can get the computer to randomly set the size between 40 and 300. And that's for both width and height. And that will happen every time the mouse is clicked. So test the scene again. And when you click the mouse, notice the player now changes shape. Now it looks a little unusual because it's actually warping the character at this point. But notice that the event only runs when you click the mouse button. So uncheck this, and we're going to add one last event. We don't need to focus on the mobile section, but add a time event, the every n seconds, and we will choose every 1 second. Back to the actor, effects, and choose adjust hue, which will change the colour of the character. And we can add a random integer from the numbers and text section, and let's make it between 0 and 40. So now you can see the player is changing colour every second. Okay, so we have taken a look at a few of the common events that are used in code. You can see they run at different times, some based on user input, but they can also be randomized. We will now add the final touches to the menu scene. So first, we will add colour to the jelly beans. Double click on the jelly bean actor and then go to the events section. Now we're going to randomize the colour when the level begins, so add a when created event. We're going to add an effect to change the hue, but the jelly bean is currently white, so it has no hue, so we need to give it an initial colour. So first choose the apply effect, and then we're going to add the yellow tint at 100%. Now you can experiment with different colours here, but I find that yellow works well. Add another apply effect, and this time choose adjust hue. And we want it to randomize the degrees here. So from the numbers and text category, choose random integer. And I find that larger values give more variation. So minus 360 degrees to 360 degrees is twice around the circle. Now go back to the menu and test the scene. We should see that each jelly bean has its own colour. Because it's randomised, these will be different colours every time you play the game. The player is still changing colour, so delete the example behaviour that you created earlier. And you can actually also delete the test scene as well, because we no longer need it. Now we will create the code that allows the player to collect the jelly beans. So add a collision event, since we want the code to run when the player will be colliding against the jelly bean. Choose actor of type to ensure it runs on every scene. Set this to self, which is the jelly bean, and then choose the player actor type. Now we simply want to kill the jelly bean on collision. Final piece is to get the play button to work. First, before we do this, we need to create level 1. So create a new scene and call it level 1. And leave everything here as it is for now. Close the level 1 tab to save it, and then return to the menu scene. Go back to the events section and add a new input event. Now this will be a click on actor. Configure this to is pressed on, and then choose the play button. Now to the scenes category and to game flow. To load a new scene, use the switch to scene command. And then once this is put in, you want to choose the new level 1 scene that you just made. Now you can choose a transition style. Fade is the default. Let's try bubbles out and set a transition time. So smaller numbers work best. But you can experiment with this. You can even set a colour for the transition. Okay, so test the menu scene to see what it looks like. Okay, so I don't actually like that much. I think I will set it back to the fade. Now we have now completed this menu scene. And that's much better. In this section, we will complete the first level. So open level 1 and go to the properties section. And from here, we can change the width of a level to 82. And then we can make the background color black. Now we have a scrolling level. Okay, so in the resources for this lesson, you will find the level 1 layout image, which shows you where to place all the tiles and objects. And you can experiment with your own designs if you want. To enable the grid guide, click this button. Now notice we leave a blank bar at the bottom and top. These are for the icons and health, etc. Okay, so let's start adding the tiles. Count how many we need from the image. Now click on the tile and then let go of the mouse button. Now click and drag in the scene to draw the platform. And then choose the end right tile to finish the platform. There are 3 spaces and then a bottom corner turn. Now if you make a mistake or you draw too far, you can actually erase that by selecting a grey block and then drawing over it. You can also set a new tile to overwrite an old tile. Now this is a modular tile set, so we can make different patterns using the available tiles. Now if you finish the design based on this image. Okay, so now to add the actors. We can also actually switch off the grid for now. And to keep things ordered, let's rename layer 1 to tiles and then create a new layer called objects for the game object actors to go. Now choose the actors and select the box, placing it in position. And do the same with the jelly beans. You can estimate where the wood platform and the moving platform need to go. Now add a new layer for the player to go, which keeps the layout very organised. So we are now going to check the quality of the first level. There are probably going to be some bugs that we need to fix. First, we need to add some gravity to this level, so 55 should do. And we want to test the scene to see if it works at this point. Right, so there are some issues. Some objects are affected by gravity when they shouldn't be. And we can also see the player works, but he currently can't fall through the gaps. So go back to the actor types and start setting some of the actors in their physics section to cannot be pushed. This ensures that they are not affected by gravity. Also make sure they cannot rotate as well. And for the door, this one can be set to cannot move, as it will not require any physics in the game. We'll come back to the water drop later. Okay, so let's start closing some of these tabs to save on memory, as Stencyl runs out of memory quite quickly. So let's make sure that this has fixed the issue by testing this scene. Okay, great, that's better. And Now we still need to fix the player. So go to the actor behaviors and double click cannot exit screen to edit this code. Click on updated and here we can see quite a lot of code. Now this is checking the player's X position. Okay, and this is the left and right position. And the Y is the up and down position. And it's checking this against the width and height of the screen. So it's actually this bottom piece that needs to come out. This is what is stopping the player falling out of the screen bottom. And as soon as you pull a piece of code out, it will no longer be run. So now the player should be able to drop down through the bottom of the screen. Okay, so the scene now needs to be reset when the player dies. Back in the code, add a new event. It is an actor event and it's when he leaves the screen. It's going to be a specific actor. So set this as self, as this is attached to the player, and then exits the screen. Now it's under the scenes category and game flow. Choose reload and crossfade. And set this to 0.5. Now let's test the scene to ensure it does work. And we find that we still can't leave the scene, but now we can fall down the bottom of the screen and it does reset. Click this button and it highlights what will be seen in the final game screen. Now without the camera follow behavior, the screen just will not scroll. The player will reach the edge of the screen and simply stop. So I'm going to move this down so I can reach the other side of the screen. And we will add a pre-made code. So double click on the player and then go to the behaviors section. And we're going to add a new behavior. You will find it in the game category. Click on the camera follow behavior to assign it and leave the scroll speed at 0. Now we can see that the player remains in the centre of the screen as the camera follows him, allowing the scene to scroll. Now there's an issue with this door. So double click the door and we can see that the wrong animation is set to default. This ends with the open black door that we saw. Click the star to default the closed door. Okay, finally put the moving platform back in position. Now we're going to get the moving platform to start moving up and down. So double click the moving platform actor and check the physics. This should be set to cannot be pushed. This ensures it always stays in place when we jump on it. Add a new behavior and choose from the motion category, back and forth vertically. And we want the initial direction to be down. And it goes 100 pixels in both directions. Uncheck change direction on collision. We want to uncheck this because otherwise we would have issues when we jump on the platform. Okay, test the scene to ensure it works. The next thing we want to work on level 1 is the water drops to be spawned from these points. Now go to the actor behaviors section and create a new behavior called spawn point. We want a water drop to be spawned into the scene every 2 seconds. So which event would be best? Now would it be from the basics, or the user input, or time? And of course it would be from time. Every n seconds. And we want it to be every 2 seconds. Now to spawn something, go to the scenes category and choose create actor. Choose the water drop. Now it is asking where we want to create the water drop. The X and Y are these coordinates found on the bottom right. Now if we set specific coordinates for a water spawn actor, then the other spawn actors won't work. So go back to the actors category, and from position we choose the X and Y position of self. So the water drop is created wherever you have placed a water spawn actor. Now attach this script to the water spawn actor. Now let's check the water drop. And the splash is actually set to the default animation, but we want the drop to be the default. Let's test the scene to ensure it works. Okay, so it's spawning at the right point, but it's not destroying the drops, and we can also rotate them. Now go to the physics in the water drop actor and set can rotate to no. And we want to add a new event. This will be a collision. We want the command to run when the drop collides with anything. Find the kill actor command and drag this into place. Okay, so it's working against the tiles and also against the player. But we do want to make sure that we use this splash animation. So drag out the kill actor for now and find the switch animation command under the draw section of the actor category. Now we have to enter the name of the animation, which we can see here. It must be spelled in exactly the same way. Now we can see each frame lasts 100 milliseconds. And there are 7 frames. Okay, so from the flow category, go to time and choose do after 0 seconds. Now enter 0.7 seconds, which is 700 milliseconds, and then attach the kill actor. This will destroy the water drop after 0.7 seconds. It's just long enough for it to play out the splash animation. Okay, so there's an issue with the animation and the collider at this point. So we can see that there are too many frames. Remove the first 3 frames so it begins at the actual splash animation. Now let's check the collisions. So the first one is fine, but we can see that the second one hasn't been set. So let's use the numbers for the first one to set up the second animation collider. Okay, so let's now test the scene to see if the issue has been fixed. And that's much better. And it works with both the tiles and the actor. We are almost done using the pre-made codes that come with Stencyl. And from the next video onwards, we will be creating our own codes. But we do still need to get this wooden platform moving. And we can also sort out the enemy movement later. So go back to the dashboard and duplicate the wood platform. And rename this to wood platform moving. Now we will add a new behavior to this. So it's under the motion category and it's back and forth horizontally. Now set the initial direction to left and then ensure you uncheck this change direction on collision, otherwise you'd have issues when you land on it. And change the speed to about 8. Now back in the scene, delete the old wooden platform by pressing delete and then replace with the moving wood platform that you've just sorted. And to make it easier to test, move your player closer to the platform and then test the scene. Okay, the platform works well. We have now completed the basics, and in the next section it will be a bit harder as it involves more complex code. There are still a number of things to work on in this level, which we will do in the next section, such as getting the enemy to move and damage the player. We also want to count the jelly beans collected and sort out the graphical user interface. But before we move on, we can take this opportunity to check our progress so far and look for any bugs in this level. So, first of all, test this scene. If we wait a while here and then move backwards, we can see that the water drops are acting a little strangely. So when it appears on screen for the first time, we can see multiple drops. Now this bug is actually quite easy to fix. And here's another issue. The player can't jump high enough to reach this ledge. So let's fix these bugs. Okay, open the water drop and add a new behavior. It is under the motion category. We need to choose always simulate. This ensures the drops are falling even when they are not on the screen. Now modify the player. We need to increase his jump force to about 55. And let's test the scene to see if that works. Great, so the water drops are now fixed. And the jump force at this moment seems a bit too high. So try lowering it to about 45. Create a new scene behavior called score counter. Now you'll notice two types of attributes. We want game attributes. And click the create new game attribute and you will see a few different types. Now we want the number, since the score is going to be a number, and call it score. It shows up in the list. Now there are two sections here, the getters and setters. One is to get the current value of the score and the other to set the new value. Now create the when mouse button is clicked event. And the first thing you want to do is run the command, which is set score to. Then you will get the current value of the score. And you will then want to add 1 to that score. So this is then included in the command, so it will now set the new value of score, overwriting the older value. So close the tab to save this for now. We are now going to display this score counter on an example scene. So create a new scene. And we will call it GUI example and make the background black. Okay, so we're going to display the score in the center of the screen. So first we must create a new font and call it score font. Now this is the default font, but we want it to be white on a black background. And I might even increase the size a bit. Okay, so now open the score counter scene behavior. And to display text, we need to add a when drawing event. Go to the drawing category and select the styles section and drag in set font and then choose the new font that we just created. And now go back to the drawing section and drag in draw text. And we're going to place the score game attribute in this first parameter. Now we must choose where to place it in the X and Y positions. So, using these coordinates in the bottom right, choose where you want it to appear. So type 216 in the X and 260 in the Y. Attach this behavior to the GUI example scene. And then test the scene to ensure it works at this point. Great, so every time we click the score, it goes up. Now at the moment it's just a number, so we need to tell the player that this is the score. So under the numbers and text category, click on the text section. And use this text and text to combine two different things. Now use anything as text to convert the number into text, and this will go into the right, with the score inside the anything as text, and then write score in the left side. Now place all this in the draw text command, and then we want to test the scene to see if it works. You will create the number of jelly beans collected and also a health number. Use this code to help you to create it. You will need to create two new game attributes, one for jelly beans and one for health. The health should have an initial value of 3. And don't forget to also use the when drawing to display the numbers. Now you will be setting it all onto the level 1, the jelly beans at the top and health at the bottom. So create a new scene behavior called GUI. And use the when drawing event to draw the text. Don't forget to attach the behavior to level 1. Okay, so you should now have some text on your level 1 screen. There should be a number of jelly beans on the top and a health number at the bottom. When you collect jelly beans, the number on top should increase. And let's go inside the events. For the jelly bean, there should be two new game attributes, jelly bean and health. Now under the collision with player, it gets the number of jelly beans and then adds 1 to it. Now in the GUI behavior, we can see the score font is being used under a when drawing event. Then it displays jelly beans and health at these coordinates. If you click the settings button and check the attributes section, you can access the game attributes. Now we no longer need score as that was just an example, so click remove to get rid of it. Okay, you can also delete the GUI example scene. Now go to the actor types and duplicate the jelly bean. Rename it as jelly bean GUI. Okay, so from this, remove the collision code from the event section. And we also want to remove its collider. And then under the physics section, we want to set it to cannot move. So this is for display only to show the player the number is related to the amount of jelly beans collected. Now create this new tile layer and rename it as GUI. You can then place the jelly bean GUI actor in position. Now when you test the scene, you will see the new jelly bean will not stay in place as you scroll along the scene. So at the moment it acts just like any other object. But obviously, because it's GUI, graphical user interface, we want it to be fixed to the screen. So in the events section for the level 1 scene, add a when created event, because we want this to run once when the level is first created. And in the actors category, go to the draw section, scroll to the bottom to find the anchor actor to screen, and then choose the jelly bean. Okay, so now you will notice that the jelly bean now stays in place. Okay, so go back to the dashboard and duplicate the heart actor. Let's rename it as Heart GUI. And then you also want to remove its collider. And then also in the physics section, you want to set it to cannot move. Okay, so now back on level 1, you can add the art GUI in position. And then under the events, right click on the anchor command to duplicate it. And then choose the art GUI. Okay, so test the scene now to ensure it works correctly. We will now include a total number of jelly beans to collect. Open the GUI scene behavior and drag out the jelly bean attribute and place it anywhere on the canvas. Now go to the numbers and text and then to the text section, and we want to use the text and text command. Now put the jelly bean attributes into the left side and then write a slash followed by space and then followed by 20, which is the total number of jelly beans on level 1. Now put all this back into the draw text and then let's test the scene. Open the GUI scene behavior. Let's create the seconds game attribute, giving it an initial value of 20. Now let's display that on the level 1 scene, so drag in a draw text command and then add the seconds attribute to the first parameter. Now open level 1 and locate the X and Y coordinates for the placement of the time. Now type 285 into the X and 10 into the Y. Now add the every n seconds event, making it run every 1 second. Now set up the game attribute so that it subtracts 1 from the value of seconds every time this event is run. Inside this event, add an if from the flow category. Now add a less than or equal to comparison. And drag the seconds game attribute into the left side and then type 0 into the right side. Go to the scenes category and game flow section. Add a reload command and then type 1 second as the duration. There are multiple transition styles, but keep crossfade for now. So when the level is loaded, it sets the timer back to its original value, which in this case is 20. You can also click on Settings and go to the Attributes section and set the initial value of seconds to whatever you want it to be. But the value in the onCreated will actually overwrite that number. So we can temporarily set the timer to a lower value for testing purposes in the onCreated event. So notice now how it resets the time nicely. Okay, so the countdown and the reload are both working well at this point, but we actually want to display the real time in both minutes and seconds. And we're going to add a new game attribute called minutes. Now click on the settings button and go to the attributes. Ensure all the initial values are reset to 0. This avoids issues in future sessions. Now click on when created and change seconds to 59, and then add set minutes to and then type 2. Now this part of the code is working as we need it to, but we don't need the if statement in this particular event. Add an updating event. So add an if from the flow category and then add a 0 less than or equal to 0 comparison. In the left parameter, add the seconds game attribute and type in the right parameter 0. Now, when that happens, it will subtract 1 from time and reset the seconds. Set minutes to minutes minus 1. Now, to reset the seconds, simply set seconds to 59. So on the drawing event, drag out the seconds attribute. Now add a text and text command and put seconds into the right. And then type space and then a colon and another space in the left. If you don't add the spaces, then the numbers are bunched too closely together. Now add another text and text. Attach the seconds text and text in the right, then put the minutes game attribute into the left. Now put all that back into the draw text. Okay, let's test the scene. So this looks much better. There is a small issue we need to fix with this timer. In the GUI scene behavior, go to the created event and for testing purposes, change seconds to 15. Now test the scene. It goes into single figures when it is below 10. Now we need it to be in double figures, so 09, 08, etc. If you want to try and fix this yourself, pause the video now. Otherwise, I will show you how to fix this. Add an if from the flow section and drag the draw minutes and seconds into this. Then drag the 0 greater than 0 comparison into the if and put the seconds game attribute into the left and type 9 into the right. So this command will run if seconds are larger than 9, so from 10 upward. Right click on the if and choose duplicate to create a copy and then reattach to the when drawing event. Replace the seconds are greater than 9 with the seconds are less than 10. Add another text and text from the numbers and text category. Type space, colon, and then space again in the left. Then 0 in the right. Now drag that into the parameter to the left of seconds. So now it will display minutes and then colon, 0 and then seconds when seconds are less than 10. Great. this looks much better. Now we're having double figures when it gets less than 10. When time reaches 0, we want to go from the level 1 scene back to the menu. So open the GUI scene behavior. Now these are all working properly. We are going to add some code to the updating event. Now this conditional if statement is working fine. If minutes were 0, this code would still continue to run, making minutes fall into the minus numbers. So we need to apply a cap so that the minutes cannot fall below 0. Add an if statement inside the existing if statement. This means that seconds must be equal or less than 0 for this new conditional if statement to run. So add an anything equals anything comparison, then place the minutes game attribute into the left and type -1 in the right. Now set minutes to 0 and set seconds to 0. This makes sure that if minutes ever enters the minus numbers, it is reset to 0. Add another conditional if statement below the rest of the code. Now we want to check if both minutes and seconds are equal to 0. So use the AND boolean, then drag out two sets of 0 is less than or equal to 0. Place the minutes game attribute in the left of the first one, and then the seconds game attribute into the left of the second one. Set both to 0 and then drag into the left and right of the AND boolean. Drag all this into the bottom if statement, then add the switch to scene command. And from there, choose the main menu. So when both minutes and seconds become 0, then it will change over to the menu scene. Now open level 1. For testing purposes, change the when created numbers for seconds and minutes. Make minutes 0 and seconds 5. Now test the scene. Okay, great, that works fine. Now set these values back to minutes 2 and seconds 59. We are now going to get the player to jump on the box to retrieve the key inside. Create a new actor behavior called getKey. The event is going to be a collision with an actor of type. Now set this to self and then choose player for the actor type. We only want this to activate if the player is on top of the box. Now if the player touches the sides, it should do nothing. There is a category called collisions which can detect if a specific part of the object has been collided with. Set this use an if condition, then place the top of actor 1 was it. Actor 1 is the box because this script will be attached to the box. Actor 2 is the player or the other actor. We're now going to change the animation to the key. Now remember to spell the animation name in the way it appears in the actor appearance. So it must be spelled just like this. Attach this script to the box. And let's test the scene. Now nothing happens when we touch the sides, but when we jump on the box it turns into a key. Okay, so this code is being run immediately. We can add a delay to this. Go to the flow category and the time section. Drag in a do after 0 seconds. Type 0.3, then drag the switch animation back into this code. The box will turn into a key after 0.3 seconds. Then we can add a do after 0 seconds. Now type in 0.5, then we want to add a kill actor command. This will destroy the key 0.5 seconds after the player lands on it. So test the scene again. Great, just long enough to see the key. Now we need to display the key at the bottom of the screen to indicate that we have picked it up. Go back to the getKey behavior and add a new game attribute called haveKey. It will be a boolean set to false to begin with. Drag the set haveKey above the kill self and set it to true to indicate that we now have the key. Add a when creating event and drag in the set haveKey attribute. And we want to set it to false. This is so that it resets every time the level is reloaded. Now we want to add the key icon to the GUI. We want it to display when the player breaks the box and picks up the key. Go back to the actor types and duplicate the box and key actor. Now rename this as key display. Open this and set the key to be the default animation. And we want to remove the behavior. Now delete the collisions. Then we want to set the physics to cannot move. Save this. And then open the level 1 scene and add the key display to the bottom of the screen. In the events section, duplicate one of the anchor commands and set the new one to anchor the key to the screen. Add a new actor behavior and call this display key. Add a when creating event. Then go to the actors category and the tweening section. Choose fade in actor. Now we want to fade out the key over 0 seconds so that it is invisible when the level begins. Add a when updating event. Include a conditional if statement and an anything equals anything comparison. Place the haveKey attribute in the left and place true in the right. Now include the fade-in command from the actor category. This is an exact opposite of what we did in the when creating. Now this code will work, however this command is going to be executed every frame throughout the level, meaning the game will be fading the key in on every frame of level 1. Now this is not good practice. I will show you how to fix this in a moment, but first I will show you that this code will work. So it definitely displays the key. However, it is actually fading it in every frame at the moment. Now let's fix this code so that the fade-in command is only executed once when the player picks up the key. So we will use a local attribute. Now these are different from game attributes in that they can only be used in the one behavior they are associated with. Click Create Attribute and you will see a larger list of types than is available with game attributes. Now choose the boolean and we will call this key GUI. You can access the attribute properties from the tab at the bottom. Now this boolean is set to false to begin with. So drag out the fade in self command And then we want to place a conditional if statement inside the if av key is equal to true. Now set this to key GUI is equal to false, which is its initial value. Then set key GUI to true underneath the fade in self. So when the player picks up the key, the av key attribute is set to true, which then triggers this command. As long as key GUI is false, after the very first frame, we set key GUI to true, ensuring that command cannot be executed again until the scene is reloaded. Okay, this works and it's certainly now more efficient. We are now going to work on damaging the player and reducing the amount of health or lives, if you want, whenever the player is hit by a water drop. Create a new actor behavior called player damage. Add a collision event. It will be with a specific actor of type. Set the actor to self, which is the player, and the actor type to the water drop. Now it makes sense now to set the health game attribute to -1 each time the player is hit by the water drop. It's certainly the way that we've done it before. But this is going to give us an issue when we test the game. For now, I'm going to demonstrate what will happen using this format. So attach this to the player. And let's test level 1. Okay, so it's taking too much health off the player each time we are hit. So to explain why this is happening, open the water drop actor and go to the events section. This is the issue. The water drop is not destroyed for at least 0.7 seconds. Now the collision is being called each frame while the water drop is still active. So open the player damage actor behavior. Now one way to fix this could be to kill the water drop as soon as it hits the player. Now change this from self, because that would kill the player, to last collided actor, which is the water drop. Test the scene now to see what happens. So it only takes 1 off the health, and it's killing the water drop before the next frame is run. But it is no longer playing the splash animation, and I think it looks better when it plays this. But that means the water drop must last the extra 0.7 seconds. So open the player damage behavior. Now we don't need this, so let's get rid of it. And we're also going to move this. So click Create Attribute and call it Lose a Life. You will see you have more options for the type. We want this one to be Boolean. Actually, I'm going to make this true, as that makes more sense. So if lose a life is equal to true. Now click on the Attributes tab at the bottom and you can see that this is false to begin with. Click True as its default state. Now create a new custom event under the Advanced category. Let's call it Damage Player. Double click the item on the left to rename that and call this Damage Player as well. Now we have to trigger the custom event from the collision event. So find Trigger Event under the Behaviors category. Now type the name of the event, which is damage player, and it must be spelled exactly the same as the custom event. Right click on this and copy. Then paste this into the damage player event. Now you can get rid of the old command. Click on the attributes category in the setters section and then set lose a life to false underneath the trigger event command. This now deactivates this code after one frame, preventing it from running multiple times. Drag an if statement, then set it to check if lose a life is equal to false. Now add the set health command. Go to the time and drag in a do after seconds, then type 1.5. Now set lose a life back to true, resetting it so the player can be damaged again. Test the scene to see if it now works. Okay, so it looks like it doesn't work. Let's try and find the problem. Go back to the player damage behavior. Now this is calling the damage player custom event, and we can see it is named exactly the same. So the problem isn't there. Lose the life boolean is true to begin with, which is fine. But this is the problem. We are setting the lose a life to false after calling the event. So change it so it is set before calling the event. Computer runs the code in order, and it required the lose a life to be false to run the custom event. So now we can see that it works perfectly. There is an issue with it running into minus numbers, but that is easy enough to fix. We are now going to work on a visual effect to indicate when the player has been hit by a water drop. So open the player damage behavior. And we will now create a new custom event when the player is damaged. So add a new custom event from the advanced section. And call it player hurt, and then also rename the custom event on the left. Click back on the damage player event and add a trigger event command. Type player hurt. Now this must be spelled exactly the same as the custom event you have just created. Go back to the player hurt and go to the actors category and the effects section. Drag in apply effect. Now drag in adjust brightness and set it to 80%. Go to the flow category and the time section. Drag in do after seconds. Type 0.1 so the effect is added for a fraction of a second. Now go back to effects and drag in remove all effects to return the player back to normal. So when the player is damaged, he will light up for 1/10 of a second, indicating that he has been hurt. Now let's test the scene. Okay, this looks good. We want to now get the Flamo enemy to start moving left and right. So go back to dashboard and actor behaviors. Right click on back and forth horizontally and duplicate. Then rename the copy to back and forth enemy. We're using two of these because later we have to modify the original and we don't want that affecting the Flamo enemy. Attach the new behavior to the Flamo enemy. Choose left as the initial direction. Now these numbers are fine, Ensure that change direction on collision is checked. This makes sure the enemy moves the other way when he hits you. So for testing purposes, let's move the player closer to the enemies. And now let's test the scene. The enemies are moving left and right, but as you can see, the top enemy is going too far to the right. Now they do change direction when they hit the player, and they actually push him away as well, which looks quite good. And this bottom one works perfectly. Your task is to fix the enemy movement for the top enemy so that he doesn't go beyond the wall to the right. You also need to modify the player damage so the player is hurt when he walks into the flame-o enemy. Then you need to fix the falling outside of the screen. It needs to take 1 health off each time. You can also get the player to jump on the enemy's head to kill them. Now, if I put the player back to the start of the level, and then I'm going to test the scene again. So the health goes into minus figures. Ensure it goes back to the menu when it reaches 0. So the health should now go down by 1 each time you fall below the screen. And the top enemy should be in the right place. And you should also damage the player, taking off just 1 health. Now there is an issue here with the menu reloading constantly. So the top enemy was simply moved further to the left, and this solved the issue of him going beyond the wall to the right. Now the player can jump on the enemy's head to kill him, but as we can see, it also takes 1 health from him each time. So we actually need to fix that. First thing I did was modify the cannot exit screen behavior. I have added a -1 from health game attribute to the exit screen event. Then I modified the player damage behavior. So I made another collision event identical to the water damage event, but this time self hits a flame-o, and it calls the custom events which have not changed. But I have added an updating event that checks if health is equal to or less than 0. It then caps health at 0, not allowing it to go into minus numbers, and it loads the main menu scene. I have also modified the flame-o actor under the actor types category. In the events section, I have included a collision with actor type, setting it to self. It's a player. Then it detects if the top was hit, destroying the flame-o. Now let's take a look at this main menu. Go to the events and add a when creating event. Then set the health game attribute to 3. This resets the lives and will stop it from trying to reload constantly. Now under player damage, go to the flame-o damage event. I have renamed this so yours might be named something a bit different. Add an if statement and then drag in the top of actor 1 was hit from the collisions category. Now the player is actor 1, but the flame-o character is actually actor 2, so change this. Then change was hit to wasn't hit. Now this runs the damage code only when the player is hitting the flame-o from the side. It will not run when he hits the head. So test the scene now to ensure this all works. So he does take damage from the side, but now he doesn't take any damage when he hits it on the head. And the menu now works and loads when the health is back to 0, and then it's reset to 3 when you play the level again. Now notice how the player is not hurt straight away. This is because of the delay of 1.5 seconds between damage. Now you can sort that out if you want, but I am happy to leave it as it is. Now we're going to work on displaying a message at the bottom of the screen, and this will be triggered when you approach the door. So it will tell you to collect all the jelly beans, or it might tell you to find the key. Okay, so open the GUI scene behavior. Now we're going to leave a comment for ourselves to keep the code organized. So find the comments under the flow category and debug section. The comment tells us that each message is going to be called on a specific message ID. This can be triggered at different parts of the game. Click on Game Attributes and create a new number attribute called Message ID. And add a conditional if statement and then an equals to comparison. Now place Message ID game attribute in the left and then type 0 in the right. This is kind of like a boolean, only it is not restricted to just true or false. Add a draw text command from the drawing section and type blank for now in the first parameter. This will eventually be completely blank on the screen in its default state. Find the coordinates for the message on the scene window. Now type 216 in the X and 451 in the Y. Go to the created event and then set message ID to be 0 when the scene first begins. So this prevents random messages to appear when the game first starts. Now test the scene to see what it looks like at the moment. Okay, that's in the right place and it looks good. Back in the code, right click on the if to duplicate. Change message ID to equal 1 and then type "you need to find a key to open this door" as the message. Now go to created and change message ID to 1 for testing purposes. So the scene will now start with a key to open door message. Okay, so it's in the right place, but the font is too big, taking up too much space. So create a new smaller font for the messages called Message Font. Now set the size to 14 and then change its colour to white. And then you can close the tab to save it. Now go back to the drawing event in the GUI code, go to the drawing section and to styles, then drag set current font underneath the grey comment block and choose the message font. This will set the smaller font for the messages only. Test the scene to check the difference. Now that's much better. It doesn't take up as much space and the time and the other UI text is still the same size. Now duplicate the bottom if statement again and change the message ID to 2. Now type the message "collect all the jelly beans." And under the drawing event, get rid of the blank message, leaving the first parameter empty. And it will have a red error, but don't worry about it because it will still work fine. Set the message ID back to 0 under the created event and test the scene to ensure it displays nothing in its default 0 state. Now we need to create a trigger that changes messages. First, duplicate this if statement and let's create a level complete message for when you have both the key and have collected all the jelly beans. This is message ID 3. Just type level complete. Go to Add to Behaviors and create a new behavior called door open. Now add a when created event. Create a new game attribute called open that is a boolean and set it false to begin with. Now set open to be false when created. This ensures that if the level is reloaded, that the door will start out as closed. Open the door from the actors category and attach the door open behavior. Notice how it tells us that there are no attributes to configure. We created the open game attribute, but that cannot be set from this screen. If we create a local attribute, however, we can set this from this screen. So click Edit Behavior to continue editing this code. And add a new attribute and select the type of region, and we will call it door region. This will allow us to attach a scene region to the door and detect if the player has entered that region, which will trigger a change of message. I reopen the door and you will now see that we can configure that attribute, but the region must be set in the level itself when attached to an actor. So click Edit Behavior to continue editing the code. And add a new attribute called Total Jelly Beans and set its type to a number. If we check the Attributes tab at the bottom, we can see that its default number is 0. This can be set on each level to be a different number. Now reopen the door actor again to refresh, and you will now see we can type a number into the code from the Behaviors section. So we can change this Total Jelly Beans number. Continue editing the code. Add a new event from the Actors section. The enters or leaves a region and an actor of type. And choose the player for the actor of type, then choose Attribute for region and select the door region. Now add a conditional if statement, then an equals comparison. Drag the avKey game attribute into the left parameter and choose false for the right parameter. This will then display a message when the player has not yet picked up the key. To do this, drag in the setMessageID and set it to 1, which is the key message from the GUI code. Now drag in another conditional if statement, and this time use an AND boolean operator so we can check for 2 conditions. Drag in an equals comparison into both left and right of this AND operator. Now the left should have a key is equal to true, and the right should state that the game attribute of jelly beans is equal to the attribute of total. So level 1 has 20 jelly beans. When the player has collected them all, this will then become true. So actually this should be a not equal to comparison. When the player has not collected all 20 jelly beans but has the key, it should display the collect all jelly beans message, which from the GUI we know is message ID number 2. So set message ID to number 2. Now repeat the process again for the you win message. So when the player has the key and has also collected all the jelly beans. So that's a simple equals. So now we can use that comparison because the collected jelly beans should be equal to the total jelly beans. And the message ID should now be set to this number 3. Finally, we have to set the open game attribute to true. This will trigger the door open animation. Add a new updating event. Then drag in a conditional if statement and an equals comparison. Check if the game attribute of open is equal to true. We want to change the animation of the door to open, so using the animation name, which must be spelled exactly the same. Go to the draw section of the actors category and drag in a switch animation, and enter the name of the animation, which is open. Now go to the flow category in this time, in the time section, and add a do after seconds. Now we want the door animation to play, and then afterward load up the next scene. So you can count the time in milliseconds. Roughly about 2 seconds should be enough time. Then go to the scene category and the game flow section and add a switch to scene. Now because we haven't built level 2 yet, we can just switch back to level 1 for now. Add another event from actors. It should be an actor type, enters or leaves a region. And choose the player, and then exits, and choose the door attribute. Now set message ID to 0, so when the player walks away from the door, the message should then disappear. Finally, ensure that it is set to the door actor, which I think it already is. Now we can set up the door in level 1, so let's open the level 1 scene. Click the grey box button on the left to draw a region box around the door. This is invisible to the player, but used by the computer to trigger the code we have just created. Now click the globe icon to return to World Editor, then select the door and click the inspector in top right. Click the Customize box to access the door code, and you can now see we can attach a region to this door. Select the region 0. We can also type in the total number of jelly beans, which is 20. Test the scene to ensure it works. Walk over to the door. It displays the correct message because we don't have the key yet, and it disappears when we walk away from the door. Now go and pick up the key and then go back to the door again. Great, now the message has changed to the correct one. So open the GUI scene behavior and duplicate the bottom if statement. Change message ID equal to 4 and then type stamp on fire to extinguish it. You can now close this, and then we're going to create a new scene behavior, and we'll call this message manager. Now let's create a new region attribute and call it message region. Now it doesn't actually show up until you've created an event on the left, so add a when created event. Now add an actor, actor of type enters a region event. And choose the player. And then select the message region attribute for the region dropdown. Set the message ID to 4, which is a new message about stamping on fire to extinguish it. But if we type in a number, it will only work on level 1. So instead, let's create an attribute called message ID, which is going to be a number type. So message ID, which is the same name as the game attribute. Drag this message ID attribute into the blank parameter. You will notice you can have the same name between attributes and game attributes. Now repeat the process to switch the message off, reverting back to message ID 0 so that it then becomes blank when you exit the region. Right click and copy this command and then paste it into the when created to ensure that it is blank to begin with. Now attach all of this to the level 1 scene. And you can now see that we can configure the attributes from the behaviors screen. Now we need to draw a region around the flame or enemies so that when the player enters this, it will tell him how to kill the enemies. So we can choose that region from the behaviors section, and we can also set the message ID to 4 from here, which is the correct message for the flame or enemy in the GUI scene behavior. For testing purposes, let's move the player closer to the flame or enemies. And then test the scene. Okay, so the message is displayed, but notice that it flashes on and off the screen. That needs fixing. It would also be better if it only displays once until you kill the enemy and then disappears for the rest of the level. So click the region editor to see the region and then click on the actual region. And then we can use these coordinates in the inspector to resize this so that it covers a larger area. And this will actually fix the message actually flashing on and off the screen. So a width of 360 and a height of 420 should work. Now open the message manager scene behavior to continue editing it. And we want to deactivate the message after it has been displayed once. Create a new Boolean attribute called deactivate. Now it should be set to false to begin with. And drag in a new conditional if statement and an equals comparison. And then you want to check if deactivate is equal to true. And then when the player exits the region, set the deactivate attribute to false. So this prevents this message from being displayed again, ensuring it can only be displayed once when the player enters the region. Open level 1 and go to the behaviors section. Under the message manager, click on the deactivate to set it to true. And that will display the message to begin with. Now that level 1 is complete, it is a good idea to make a backup of the project file at this stage. If there are any errors in future sessions, you can then always reload this project, knowing that it works fine at this stage. Click on File and Export Game. And then you want to give it a suitable name so that it makes sense. I'm calling it Mining for Jelly Beans Level 1, and then save the file. This is also a way that you can move your game onto other computers to continue editing. We get a message telling us that it has saved and where it has saved to. and it then also opens the file location. Notice that this is a Stencyl project file, not a finished game file, so it can't be played like this outside of Stencyl. Later on we will publish the game when we have finished so that you can play it without Stencyl. So great, you have now created a backup save of your game.